this type of wave, I said this type of wave is a transverse wave, and I said it's because it's the oscillation is perpendicular, so at right angles to the wave propagation. Now you can see the wave propagation is from left to right. The oscillation is up and down. So you could do that could be the oscillation, and that could be the propagation. And this could be rotated. This little image could be rotated like this. And now we can write transverse. So this is a way to remember the type of wave that we're looking at, transverse. So, and the word, so what I'm showing is that is perpendicular. That's right angles. You understand the word perpendicular? Yeah. So 90 degrees. So this we would say the oscillation is perpendicular to the wave propagation. We've talked about frequencies, the number of waves per second or the number of oscillations per second. What else can we measure in a wave? The other thing one of the main other things we can measure is called the wavelength. One of the other things we can measure is called the wavelength, and it's a distance between two identical points. So I could take the top of the wave, make sure you get the top, not just left of the top or something like that. We don't want to do that. We want to make sure we get the very top if we're going to use this method. And we measure the distance from one identical point, one point to the next point that looks exactly the same. And we call that the wavelength. The symbol for wavelength is a Greek letter which looks like that. That's called the letter is called lambda, but basically it's just that's what the wavelength is. So you could also measure the wavelength from any other two identical points, like this one here. So we could just write lambda. The symbol for frequency, by the way, is little f, and the unit for frequency is, it says oscillations per second. We can write hertz. Hertz just means the number of oscillations per second. What else can we measure about a wave? We can measure how high up it goes or how strong each oscillation is. So this little motor could be going back and forth very, very quickly, but not with very much force each time, or not with very much movement each time. In this case, you can measure the amplitude from the middle point to the top there. So that would be the amplitude right there. The reason why we do it from the middle point is because we want to know how much has it moved from where it would be if there was no wave. If there was no wave, it would be along this dotted line here, just be sitting still. But because there's a wave, it's moved up and it's also moved down. So don't measure it from the bottom to the top. Okay. However, if you do measure it from the bottom to the top, that would be 2 times the amplitude. So if, for example, that's the only measurement you had, then you could the bottom to the top would be 2 times the amplitude. Okay, so we've measured the frequencies, the oscillations per second, measured in hertz. The wavelength is a distance between two identical points. That could be measured, well, I guess it would be measured in meters, really. But obviously you can measure anything. The standard unit is meters. Amplitude depends on the type of wave. So in this case, we would measure it also in meters or centimeters, but it depends what type of wave it is. So if it's a sound wave, we're actually measuring the change in air pressure, and so the amplitude will be measured in change in air pressure. So those are two things. So one of the things I'll talk about is the difference is related to frequency is called time period. And the time period is measured in seconds, and it's the period of time of one oscillation or wave. So the period of how long it takes for one wave to go by, or how long it takes for an entire oscillation. Okay, and this is all these ways of measuring it can be done with all types of waves. We're going to look at another type of wave eventually, other than transverse. but we'll leave that